Good day to everyone. This is the session regarding intermediate chemistry that is very much fetching for your international entrance and competitive exams as well. India is conducting JEE Advanced, JEE Mains examination that is for NIT and IIT admission that is the technical domain. All across India, twice a year the exam will be conducted. NEET exam will be there all across India that is for the medical entrance exam, right? So in addition to this one, Telangana government and Andhra Pradesh are conducting MCET examination to get the admission into the BTech stream, where it is the technical domain. So, and general studies content will be there for all the competitive exams you are preparing for any government organized examinations, government job aspirants having general studies as the common question paper where general science content will be there. The session what we are fetching, what we are discussing is very much helpful towards your that preparation as well. Let's go with the detailed explanation. In the first one, we gone with the Nobel Prize accorded in the year 2017 in the field of chemistry. Right. Let's go with the detailed explanation regarding this Nobel Prize, which is accorded in the year 2017 in the domain of chemistry. Right. The Nobel Prize in the Chemistry 2017 was awarded jointly to Jacques, Jacques Dubachet, Joy Chim, Frank, and Richard Henderson. Let me repeat. Jacques Dubchet, Joachim Frank, and Richard Henderson together they achieved the Nobel Prize in the field of chemistry for the year 2017 for developing cryo electronic microscope. It's a kind of new invention entirely changed the world of the tiny organisms which were not seen by the normal eye. And being it is a high resolution, that will give the determination of biomolecules which were present in the solution form. So this is the way a new invention, the kind of device they developed in order to monitor, in order to go for the detailed examination of living organisms which are in tiny diameter in the nature. So that kind of analysis becoming more easy process by the invention of cryo electron microscopy. For that purpose, the Nobel Prize is accorded in the field of chemistry in the year 2017. These are the scientists contributed for the outstanding invention of that electronic microscope. Jacques Dobchet and Joachim Frank, Richard Henderson, these three together contributed for the development, and the 1/3 share is given for the Nobel Prize, that is the most prestigious award all across the globe. And this is the detailed info regarding all three scientists who ever contributed for this electronic microscope. Jacques Dobchet belongs to the University of Lausanne in Switzerland. Joachim Frank belongs to the Columbia University in New York, United States of America. Richard Henderson belongs to MRC Laboratory of Molecular Biology, Cambridge, United Kingdom. So these three scientists together developed outstanding machinery, a device which paved the way for the tiny organism analysis for the development of cryo-electron microscopy for high resolution structure determination of biomolecule in solution form. Cool microscope technology, which paved the way revolutions in biochemistry. We may soon have detailed images of life's complex machineries. Everybody aware that any living organism, if you are taking into the consideration, so many complicated things are going inside, so many mechanisms are operated inside, so many complicated systems are running. Okay, so all are auto mechanized, so that they are going in their proper way of working, so that entire living organism survival is becoming somewhat easy, right? This is the way complicated machinery systems are available inside your physiology, right? The Nobel Prize for the chemistry 2017 awarded for these three scientists. Let me repeat again: Jacques Dobchet and Joachim Frank and Richard Henderson together for the development of cryo-electron microscopy, and that simplifies, improves the imaging of biomolecules. Biomolecules means whatever inside your organisms you can find the, for example, any tiny repair or damage is there. In order to identify, in order to visualize that kind of particular region where we have to go for the further development, further treatment, so that particular area you want to analyze, you want to visualize. So at that condition, whatever they develop a cryo-electron microscopy, very much important in order to make the tiny organisms to get visualized. This method have moved biochemistry into a new era on, because whatever unseen earlier now came into the picture. Now we can easily analyze them, easily we can observe them, so that if whichever problem you are identifying, first the thing is problem identification is required. After identifying, it is obvious to get how can we solve that one. That's the reason why, by using this cryo electron microscopy, all the organisms, all the kind of tiny particles, tiny biomolecules can be visualized very perfectly, so that you can identify what exactly the problem is, so that you can go for the treatment or curation or medication, whatever you need. So that is the way this kind of cryo-electron microscopy is the new kind of revolution in the field of biochemistry. We can say new era or new chapter was started over here. A picture is a key to understand scientific breakthroughs, often build upon the successful visualization of objects invisible to the human eye. We can't see normally, or else normal microscope not able to identify those pictures in high resolution. At that condition, whatever they developed is giving high resolution imagination. High resolution imaging is possible. However, biochemical maps have a long been filled with the blank space because available technology had difficulty generating images like molecular machinery. Whatever complicated systems you want to study, actually those are not perfectly analyzed because of lack of that technology. In order to visualize that tiny particles or tiny organisms or tiny systems whichever working on the mechanistic pathway, so that here this kind of cryo-electron microscopy is the kind of tool, we can say, which used to magnify them. So because of that amplification, you can go for the high resolution with the high clarity, so you can identify what actually, so that analysis is becoming easy, so that ease of curation is also possible. Cryo-electron microscopy changes all of this. Researchers can now freeze biomolecules, so whatever you're observing you can freeze over there. Wherever you want there, you can pause for some time and you can understand the entire thing whatever you need to know, so for longer time. So that kind of technology also we have, rather than going in a flash time. You can freeze upon where you want to trigger, where you want to make a point, so that point you can clearly visualize by making the pause over there. And that analysis is in-depth analysis you can go for, and visualization process is becoming more easy they have never previously seen. So that process, whatever we face the difficulty, that was so that totally unveiled by means of this kind of invention, which is decisive for both basic understanding of life chemistry and for development of pharmaceuticals. Whatever actually going on you can analyze first. So what things are actually going on in the minute level, at the root level, what kind of things are going on you can analyze in depth, in the infinitesimal pathway, in infinitesimal resolution, so that you can obviously go for the new pharmaceutical entities, and new auxiliaries will come into the picture in order to go for a new technical invention, what we can see here, right? So this is the way biochemistry is entirely changed because of outstanding contribution of these eminent scientists together, and revolutionary high resolution cryo electron microscopy got invented. Let's see what device is. This is the biggest device you can notice, and this entire device having the the machineries which are arranged and give the images with the high accuracy and precision as well, right? So this entire equipment can be monitored by eminent and most skillful personality, so that high what high quality results we can obtain by means of this method, right? So let's go with the question number 2. Question number 2 was collected from Cambridge Assessment International Education. In an experiment, 1.61 grams of sodium sulfate XH2O is heated until all the water is given up. The mass of sodium sulfate remaining is 0.71 grams. Okay, so initially 1.61 grams of sodium sulfate hydrated form was taken and subjected to heating. Obviously, by heating, water of crystallization got vaporized. Whenever vaporized, you will get anhydrous sodium sulfate, where water is totally vaporized, totally lost. After losing water, 1.61 now reduced to 0.71, right? So the thing is, sodium sulfate molecular weight is given as 142, water molecular weight is given as 18. So the question is, if this x moles of water used in the crystallization of sodium sulfate, what is the value of this x to be depicted? Calculate the number of moles of sodium sulfate remaining after that kind of dehydration. Whatever sodium sulfate left, whose moles you need to calculate, right? Calculate the mass of water given up. How much amount of water is evaporated, that amount to be understood. These many questions are the target for this question number 2. In order to solve this one, first of all, whichever data is given, we need to collate them. The mass of sodium sulfate remaining after the evaporation, whatever left as anhydrous form, that is 0.71 grams. And sodium sulfate molecular weight, which is already given data, that is 142. And water molecular weight is given as 18. This is known to you. The number of moles of sodium sulfate remaining. So after the evaporation anhydrous form, they are asking for number of weight, always number of moles is equal to weight by gram molecular weight, or mass by molar mass. So weight of anhydrous sodium sulfate is provided as 0.71, and molecular weight of sodium sulfate is given in the data, that is 142. 0.71 by 142 will become 0.005. This is about what? Number of moles for this anhydrous sodium sulfate. Okay. If you want to calculate how much water got evaporated, in order to calculate the evaporated water, initial weight of the sodium sulfate hydrated form you have to consider, and after the evaporation, what is the leftover anhydrous to be subtracted from that. Okay, the difference will be the water which is evaporated, that is 0.9 grams. That is one of the question in this. Calculate the mass of water given up, that will be 0.9 grams. So one of the question got answered over here. The number of moles of water, how many moles of water is there? Number of moles is equal to weight by gram molecular weight. Weight of water evaporated is 0.9. Molecular weight of water is given as 18, right? So this is known formula only. Moles is equal to weight by gram molecular weight. We are repeating the same formula. Applying for water. Water weight is 0.9 grams. Molecular weight is 18 grams. 0.9 by 18, that is 0.05 moles. Number of moles of water is 0.05. Now, X is nothing but what? X is nothing but number of molecules of water of crystallization. Okay, how many molecules got evaporated, that X to be identified. For this purpose, number of moles of sodium sulfate, number of moles of water by number of moles of sodium sulfate, this ratios to be taken. Moles of water by moles of sodium sulfate, this ratio will give you value 10. That means the 10 moles, 10 number of water molecules will be present in this. Okay, calculate the number of moles of sodium sulfate remaining. So number of moles of sodium sulfate remaining is 0.005. This is one of the question. 0.005 is the number of moles present after dehydration. Okay, then X value is taken as 10. This is one of the question. And the number, weight of water calculated as 0.9 grams. 3 questions are posed over. X is taken as the value 10, and sodium sulfate number of moles calculated as 0.005, and mass of the water given up is 0.9 grams. So all three questions got uh, clarified or calculated in a simple way by using the mole formula, right? So this is the way we can go for the answer for question number 2. Move on to question number 3. Question number 3 collected from 2016 paper number 1. A plot of number of neutrons against a number of protons of the stable nuclei exhibit upward deviation from linearity from the atomic number Z is greater than 20. For an unstable nucleus having neutron by proton ratio less than 1, possible mode of decay is, right? Unstable nucleus having N by P ratio, neutron by proton ratio, that is less than 1. Atomic number is greater than 20. So if this is the case, possible modes of decay are, how many decays are possible for this condition? Okay, so here we are plotting the graph between neutrons and the protons. Okay, so whenever this is the case, here beta minus deca, beta emission, is it possible? Orbital or k electron capture, so we have to go for this. Neutron emission and the beta plus decay, positron emission, we have to go for the consideration of all these. The expected answers to be B and D. Let's go with the solution for this one. So if you observe, N by P ratio should increase for the number of neutrons should increase and the proton should decrease. If N by P ratio is more, whatever numerator is there neutron, that value increases. Whatever denominator value, that will be decreases. Okay, N by P ratio is more, neutron number is more, proton number is less. This is the fundamental, everybody aware. Then whenever electron is binding with the proton, electron is binding with the proton, electron is of negatively charged, proton is of positively charged when bonded, so that there is a generation of neutron is possible. Neutron will be originated. This origination of neutron by electron proton combination is called K electron capture. This is called K electron capture. And whenever proton is decomposed, proton is decomposed, one of the neutron will be formed. Neutron is having 1 as the atomic number, and 0 is the atomic mass over there, and along with that one of the positive beta particle will be generated. Positive beta particle is called positron. Beta particles are of two types, negative beta particles and positive beta particles. Negative beta particle nothing but electron, positive beta particle nothing but positron. So that you have to specify beta plus decay here. Beta plus decay is possible. So in both the conditions, you can notice neutron number is increasing. Here the neutron, because being neutron is the product, neutron count obviously increases over there. And even in this beta plus decay also neutron number got increased. Whenever neutron number got increases, proton number got decreases, N by P ratio will be increased. The question is for the unstable nucleus having N by P ratio less than 1, the possible modes of decay are N by P ratio is less than 1 is noticed for orbital K electron capture and beta plus decay positron emission. These two are giving this N by P ratio less than 1. So this is possible one. So neutron emission is not the case. In both the cases, you can go for this one. Move on to question number 4. Question number 4 is collected from P block elements in specific inorganic chemistry, and boron family elements, group 13 elements were taken into the consideration, right? Crystalline form of borax borax can be taken. So whenever borax is taken into the consideration, borax formula is provided. Tetraannular B4O5OH taken 4-2 unit will be there. All boron atoms are in the same plane, all are laying on the same plane. Equal number of sp2 sp3 hybridized boron atoms are located. One terminal hydroxide per boron atom will be there. These many options are provided among all. Tetraannular is correct because within the formula only they mentioned. Here you can notice borons are four, so that it is the compound of tetraannular in nature. So within that compound, the central metals you can notice are four. So that B4O5OH taken 4 minus 2 is the tetraannular is the correct one. All boron atoms are on the same plane is the wrong one, because a third statement if correct, second statement will not be supported. Here you can notice few are sp2, few are sp3. Sp2 are having planar geometry, sp3 are having tetrahedral, so that half of the boron atoms are having one environment, another half of the borons are having second type of environment, so that all are on the same plane laying may not be possible. So that equal number of sp2 sp3 hybridized boron atoms are present is the correct one only. One terminal hydroxide per boron, each boron is having one OH. Terminal means ending, at their edge they are having one hydroxide per boron. So let's see the entire explanation. Whenever tetraannular, they are saying borox having tetraannular because B4 is said to be a tetraannular in nature. Two boron atoms are laying on the same plane because two are sp2 hybridized, two are sp3, so that only two borons are able to lay on the same plane, two borons are out of the plane, so that option B what they are saying may not be supported. Move on to option C, two borons sp2, two borons sp3 is a perfect one. One terminal hydroxide per the boron atom is also correct. In order to go for the explanation, detailed clarity we will get by seeing it's a chemical structure, where four boron atoms are arranged in such a manner they are combined, they are linked with one ether linkage. Whenever oxygen is combining both, so that is called ether linkage, right? So this oxygen is the bridgehead now. Oxygen is the bridgehead, four oxygens are bridging, and four borons are at the edges, so in the annular ring structure. Okay, so four ether linkages, and here two borons are connected with another ether. Total five ether linkages you can notice. And one more important part is here boron is having one negative charge, here boron is also having negative charge. These two are not having, so that the complex is mentioned with -2 only. Two negative charges imparted for two boron atoms. Okay, so whichever borons are present in sp2 hybridization, they are neutral, they are not having any charges, while sp3 hybridized boron atoms are indicated with a negative charge over there. So you can notice two boron atoms are laying on sp2 hybridization plane, and two boron atoms are having negative charge with sp3 hybridization. There is a kind of distinction you can notice. And one more point they are saying, each boron is accompanied by one OH. You can clearly understand. For every boron, one OH is accompanied, so that one terminal means this is the edge for this boron. So this is the end for this boron, right? So that at their edge, you can notice each boron is having OH, OH, OH in this manner. So that every statement, whatever mentioned are correct, except all borons on the same plane. Rather, only two borons are on the same plane, right? For question number 4, option A, option C, option D are correct. Move on to question number 5. Question number 5, which of the following set of properties generally decrease along the period? Period means if you are moving horizontally, that is called a period. If you are moving vertically top to bottom, that is called a group. The entire elements are arranged in a periods and groups only, right? So if you go for periods, there are 7 periods and 18 groups are located in the modern periodic table, right? So there are certain periodic trends you can notice. One is said to be ionic ionization energy. Atomic radii is also the periodic trend. Metallic nature, atomic radii, electron affinity, electronegativity, valency, oxidation potential, all these are the part of periodic trends only. Okay, the question is the properties which are decreasing along the period. If you are moving from left to right hand side, the properties whichever decreasing to be analyzed. For that purpose, let's go one by one. Ionization energy. So as we are moving from left to right hand side, gradually ionization enthalpies are increasing, ionic radii is decreasing. Ionic radii and the ionization enthalpies are inversely proportional. Larger the atomic size, smaller the ionization enthalpy. Smaller the atomic size, larger the ionization enthalpy. That means ionization enthalpy and atomic radii are inversely proportional to each other, so that both decreasing may not be possible. Metallic nature and atomic radii decreases is the correct one, because whenever you're passing from period from left to right hand direction, what happens? Size is decreasing, so that metallic nature is decreasing. Left side metals will be there. As you're slowly moving towards right hand side, non metals you can notice, so that metallic nature gradually decreases. And obviously larger size atoms are moving to the smaller tiny particles as the atomic radii decreases. So the both the properties whichever decreases in the period are a metallic character and atomic radii both. Electron affinity and electronegativity values. Whenever you are moving from left to right hand side, electron affinity increases, electronegativity increases as well. So that these properties are having ascendancy, increasable. Valency and oxidation potential. Valency means the electrons whichever can able to donate or else able to accept. So the susceptibility to release the electrons or else accept the electrons is said to be its valency. Because of loss of electrons or else gain of electrons, they can acquire the oxidation potential. Oxidation number will be assigned to them. If they are losing electrons, plus symbol can be positive convention can be accorded. If they are gaining electrons, negative convention we have to notice for their oxidation potential, right? So this is the way all these properties. Among the correct one is metallic character atomic radii decreases along the period. Let's see in detail. Across the period, as we are moving from left hand to right hand side in the period, atomic radii gradually decreases because the size of the atom decreases. Attractive forces between the nucleus and outermost electrons will be more. Why? Because in the central nucleus, as we are moving from one atom to another, let me give the simplest comparison: lithium to beryllium. In the lithium, at the central nucleus, you have 3 protons. Move on to beryllium, number of protons becoming 4. So that nuclear power got raised in the beryllium. Nucleus is becoming more powerful, so that it will absorb the outer shell electrons very strongly. Shrinking of atomic size is possible compared to the lithium to beryllium. This is purely because of strengthening of nuclear power. So, and number of shells may not be increased, rather the electrons will be added to the same principal quantum number. Two reasons you can notice. If more the shells, what happens? Distance gradually increases. That is not happening. And moreover, nucleus is becoming more strong, so that it will increase the power to pull the electrons inside, so that shrinking of atomic size is possible as we are moving from left to right hand side. Two reasons plays a role for decrease in the atomic radii, right? So, and outermost electrons increase, due to which across the periodic table, ionization enthalpy generally increases. Whenever atomic size is tiny, tiny atomic size is having more nuclear power on the valency electron, so that valency electrons are tightly bonded with the nucleus. In order to pull that electron, we have to apply the more energy upon, so that whenever energy required will be more, ionization enthalpy is also more. This is the way ionization atomic radius inversely proportional to the ionization enthalpy. Smaller the size of atom, greater the ionization enthalpy value, and vice versa you can notice. And metallic nature, if you consider the metallic nature, as we are moving from left to right hand side, as just we discussed, atomic size is shrinking. Smaller the atomic size, what happens? Valency electrons are tightly influenced by, strongly influenced by the nucleus. They are not free, they are completely under the control of nucleus, so that electrons are not free to move anywhere. So if electrons are not moving, what happens? Metallic nature is accorded. Whenever electrons are easily released, electropositivity is there for the element. So being atomic size is shrinked and electrons are tightly influenced by the nucleus, so that they are not free for the donation. Rather, the electrons are accumulated within the atom only. So metallic nature will be shrinking, metallic nature will be decreases, as as we are moving from left to right hand side. In the other way, if you go for the group top to bottom, what happens, one shell will be increased. As the shell number increases, atom is becoming larger atom is very easy to remove the electrons, outer electrons, because central nucleus may not have that extent power to monitor the outermost electron, being it is larger distance. So that electron conveniently removed and metallic nature will be raised as we are descending down the group, right? Though nuclear power increases, nuclear power also increases, number of protons increases from one group element to another group element. But the thing is, more the number of shells, more will be the distance from the nucleus to the electrons, so that electrons are not that extent shielded and free for that mobilization. So their metallic nature will be larger. So in a period, metallic nature decreases. In a group, metallic nature will be increased. In either factor, electron affinity. So electron affinity, electronegativity are reverse, are reciprocal of metallic nature. Electronegativity and electron affinity is nothing but whenever you want to you want to make the neutral atom into the anionic species, so electron must be added. Whenever electron is added, the extent of energy will be released out. How much amount of energy that is releasing during the addition of electron to the 1 mole of gaseous atom is said to be its electron affinity. Whenever atom is having stronger tendency to accept the electrons, then only electron affinity values are larger. More the electronegativity, more the electron affinity values. There is the interrelation. Electronegativity denotes the tendency to hold the electrons strongly. Bonded electrons are strongly firmly absorbed towards the more electron absorbing tendency, that is called electronegativity, right? So both the properties are most common, are gradually increases as we are moving from left to right hand side in the period. As the size is shrinking, atom is becoming more smaller in the nature, and the nuclear power will be more, and electron absorbing tendency will be increased. Whenever electron absorbing tendency is more, that electronegativity conditions will be raised over. This is the way we can go for the trends in the electron affinity. Electron affinity and metallic nature are reciprocal to each other, inversely proportional to each other. And oxidation states and valency. Whenever you go with the first main group elements, if you see the sodium or else lithium or else rubidium, potassium, whatever, all are monopositive. Only one valency you can notice. Valency is said to be the tendency to either release the electron or else to accept the electron. Both are said to be valency only, right? So for the first main group, you can notice +1 only. For second main group, +2, and third main group, +3 will be there. This is the way. There is the valency values are gradually increases up to a certain extent. After some time, the valency values gradually decreases. If you move on to halogen, for example, halogens are having natural tendency to accept the electron, and moreover, mononegative charge taken notice, again valency will be decreased, so that there is a gradual increase in the valency up to certain level, and the later on decrease in the values are there. That is not a regular order. Regular increase or regular decrease may not be noticed. Up to certain extent increase, later on decrease. This is the way valency is said to be the tendency to either release the electron or else accept the electron. Releasing electron gives the positive, and accepting the electron will give negative sign. For example, the sodium valency is said to be 1. If you go with the aluminum valency is called 3, because 3 electrons are susceptible for donation. If you go for fluorine valency is again 1 only, though it is negatively signed, but we can say valency of fluorine is 1 again, right? That is because acceptance of 1 electron only. This is the way variation in the oxidation around the period can be noticed. So by this, the conclusion is metallic and atomic radii gradually decreases across the period as we are moving from left to right hand side. For question number 5, option number 2 is the correct answer. Move on to question number 6, last question of the session. The correct order of bond angles of the compound. In order to anticipate bond angles, everybody must know about their geometry. In order to know the geometry, hybridization is important. This is the way all the topics are interlinked in chemistry, so that you can say it is more interesting, more enthusiastic. Whatever thing you are knowing, immediately by next only you can go with the new content. This is the way it will improve your zeal towards the chemistry. And we can say whenever bond angles are taken into the consideration, bond angles purely relays than the chemical geometry. In order to know the geometry, hybridization. If sp is the hybridization, one s orbital, one p orbital got combined, what happens? Sp hybridization gives the linear geometry. Whenever the molecule is linear, what extent bond angle you can notice? Linear is bisecting circle into half, no? Circle is having 360 degrees. In that 360, you are making two halves, so that bond angle will become 180. This is the way 180 bond angle is accorded for beryllium chloride, being it is a linear molecule with the sp hybridization. And boron trifluoride is of sp2 hybridization with the planarity, so that you can go for all the sp2 hybridized planar molecules are 120 bond angle. Silicon tetrachloride is of tetrahedral with sp3 hybridization, so it is the natural trend only, you can notice. That's the reason why there is no ambiguity, all are clearly mentioned. This is a clear cut question, we can say, right? Silicon tetrachloride is of sp3 hybridization, so the tetrahedral geometry is accorded. Tetrahedral geometry, obviously they will go with the 109 degrees 28 minutes bond angle. And SF6 is the molecule. Sulfur is accompanied by 6 ligands of fluorines in the octahedral field. sp3d2 hybridization will be accorded for this one. sp3d2 will give octahedral obviously having 90 degrees bond angle. So all the elements are in the straight line, so that we can go for simple analogy for this one. You can notice beryllium dichloride is a linear molecule with sp hybridization, so that you can assign the bond angle 180. Boron trifluoride is given with 120, a silicon tetrachloride with 109 degrees, and the sulfur hexafluoride is given by 90 degrees bond angle. So this is the way a decreasing order can be noticed over there. For question number 6, option number 4 is the correct answer. Very different dimensions of chemistry we got turned up, and so many contents are taken into the consideration in order to go for the serious preparation towards your examination. Definitely I will assure for that the session what we are conducting is more fetching for your examination. If you are watching in a continuous manner all the series of sessions what we are conducting, there will be a compulsory questions in your examination, because these are the content, this is the content what we collected from the authentic sources, and most repeated questions are taken into the consideration, and the logical and short way of problem solving analogy is provided for your convenience with the detailed explanation. That's the reason why I will assure for that whoever following the session very carefully, definitely go for their examination with the great success. So that I'm sincerely requesting to like the channel, comment. In order to comment, we have a question for the session. So I have a question for this session. The question is regarding hybridization. If you go with DSP2 hybridization, what bond angles are possible? Not the single one, rather it can be accompanied by multiple bond angles. You can mention what are the bond angles with respect to the DS what trigonal bipyramidal geometry. If trigonal bipyramidal is the geometry, DSP3 is the hybridization. I gave much information regarding the question. Only the thing is, what are the bond angles for that molecule, right? That can be posted in the comment box for the session, and share with the aspirants who are more serious about the examination, and subscribe the channel. We will go for a new content, and definitely informative session will be come in coming new year. So let me accomplish this session with your great patience. Thank you very much. Thanks a lot for your patient listening.